So here's the example problem. So let's say this guy's standing here and he throws a ball up into the air. Let's say that the height that the ball is released at is 0.5 meters. And for the first part, let's say that the ball is released at the speed of 10 meters per second. So it's thrown at 10 meters per second up into the air. What's the height of the ball at its highest point? Okay, well, just so we're all doing it the same way, let's put the 0 position at the ground and the positive direction up, because you could do it with other choices and it would work perfectly fine. You still have to choose a time equals 0 instant. And that's going to be based on where you know stuff or where you're trying to calculate stuff. We know the velocity there, we know the position there, where it's released. So we want time equals 0 to be the instant that it's released. And then the time t that we're going to look at is going to be when it reaches the highest point. So that's the instant it reaches the highest point. And the reason we have to choose that one is because that's where we're trying to calculate something, or that's the instant when we're trying to calculate something. And now that we've chosen those 4 things, the 2 instants, the positive direction and the 0 position, now we can start going through those variables. And see which ones we have numeric values for. So there's t, a, p0, p, v0, and v. T, we don't know. We're not given the elapsed time to get to the highest point. The acceleration we do know. We know that it has a magnitude of 9.81 meters per second squared. And then we have to think about the direction. Our positive direction is up. What's the direction of the acceleration of gravity? Down, so this is negative. Do we know the position when time is equal to 0? Yep, and it's positive 0.5 because it's on the positive side of 0. So this is 0.5 meters. Do we know the position at time t? That's what we're trying to find. We don't know it. Do we know the velocity at time equals 0? Okay, so yeah, we know that the speed is 10 meters per second. And then we have to think about what direction it's moving. At that instant, is it moving in the positive or negative direction? Positive, because it's on the way up. And then finally, at time t, when it reaches the highest point, do we know the velocity? Yep, that's 0. And so now we're just looking for an equation that has the p in it so we can solve for it, and everything else in it is known. And the one that's going to work is 2a times the quantity P minus P0 equals V squared minus V0 squared. And so we have 2 times negative 9.81. Now that I have all the units are in SI units, so I'm just going to leave the units out until the final answer. You could carry them through and the units would all match in the end if you do it right, but I don't need you to do that. Okay, so we're looking for this position P minus 0.5 is equal to 0 squared minus 10 squared. And so we have negative 19.62 P minus 9.81, plus 9.81 is equal to negative 100. So negative 19.62 P is equal to negative 109.81. And so what do you get for P? 5.597 meters. Okay, so part B. So now it's thrown a second time. And this time it reaches a greatest height of 5 meters. What was the velocity at the instant it was released? So I'm going to leave the same choices of time equals 0, time t, 0 position, positive direction. That means that any stuff, well, no, it's a different throw. So let's go through all the, let's go through these 6 variables. So t, acceleration, p initial, p, v initial, and v. We still don't know time. Acceleration is still negative 9.81. This time we don't know the initial position. We do know the final position is positive 5. No, I messed that up too. We do know the initial position is still 0.5. It's the velocity that we're trying to figure out at time equals 0. So this is what we're looking for. And when it gets to the highest point, we still know that the velocity is 0. And so it's the same equation that's going to be useful here. 2a times the quantity p minus p0 is equal to v squared minus v0 squared. And so you get negative 19.62 times the quantity 5 minus p0. 5 minus 0.5 is equal to 0 squared minus v0 squared. And so you get negative 19.62 times 4.5 is equal to negative v0 squared. Multiply both sides by negative 1. And you get that v0 is the plus or minus square root of this thing, 19.62 times 4.5. Okay, 9.39. And this is plus or minus. Okay. And actually, in math, I feel like a lot of times that plus or minus thing can feel a little abstract. You just sort of know to put it on. But in this case, those represent two totally different physical cases. One is talking about this object being thrown up into the air, the positive direction at 9.39 meters per second. And the other case is it being thrown down towards the ground. So which one of those two physically do we want to deal with? So we want that to be positive, okay? So you need to choose one of those two directions. Okay, one more part for this. So so part C, in the throw from part B, calculate the velocity of the ball on its way back down when it reaches a height of 0.5 meters. This one, it's pretty much the same, but for this one, I just want to point out something that's always true in projectile motion. So we can still, well, so our time equals 0 is going to be when it's released. Our time t is going to be when it, on the way back down, when it reaches the height of 0.5 meters. And so our variables t, a, p0, p, v0, and v. The acceleration is negative 9.81. The initial position is 0.5. The position at time t is 0.5. The initial velocity is what we calculated before, 9.39. And then we're looking for this v. And we can use the same equation again. So we get 2 times negative 9.81 times p minus p0 is equal to v squared minus v0 squared. So this says negative 19.62 times 0.5 minus 0.5. In other words, the whole left side goes away. And v squared is equal to v0 squared. You can see that if the final position and the starting position are the same, then the whole left side goes away in that equation, and you end up with just that v is equal to plus or minus v0. Okay, then you have to figure out what direction it's going. If it's on the way down, is this going to be positive or negative? It's going to be negative, so we have negative 9.39 meters per second. And that's not just a coincidence. you can see because of this relationship here, what happens when these two are the same. At, in any motion where something is launched up into the air, it's going to be the same speed on the way down as it was on the way up at that same height. Okay, so, and where does that symmetry come from? Well, if you plot a position versus time graph, okay, so here's the position, and here's the time, and this motion is going to be a parabola. Because the function is, P of t is equal to P0 plus V0 t plus 1/2 a t squared, and this a is negative. So this is your P0. The slope of that line is V0. And you can see that at any height, no matter where you are, the slope on the way down is going to be equal and opposite to the slope here. Well, if I draw a better parabola. So what that says, for example, this sounds a little ridiculous if you haven't thought about this before, but if there was no air resistance, and there is a lot of air resistance on a bullet because it's going so fast, but if there was no air resistance, if you shot a bullet straight up into the air, when it comes back down and reaches the height it was shot from, it would be going the same speed that it was shot. Okay, but so it'll be going slower than that because there's a lot of air resistance, but it'll still be going really, really fast, which is why you shouldn't shoot guns in the air on 4th of July or whatever. How long does it take for the ball to hit the ground? And let's do these together. And how fast is it going? Or let's actually say, what's the velocity? How fast is asking about a speed that's always positive. What's the velocity the instant before it hits the ground? Finish this problem. So I'm going to choose time equals 0 to be when it's released, and time t to be when it reaches a height of 0. So then TA, P0, P, V0, V. We're trying to find this time t. The acceleration is negative 9.81. P0 is 0.5. P is 0. V0 is positive 9.39. And the equation that works with these is P equal to P0 plus v0t plus 1/2 at squared. So you get 0 is equal to 0.5 plus 9.39 t minus 4.905 t squared. And how do you solve that for t? Quadratic formula, yep. So this is your A. This is B. And this is C. And what did you get for the negative one? Okay. Negative 0.05. Okay, well, we're not dealing with negative times. That happened before it's thrown. And so this is the answer. And then to find the velocity at that instant, you can use the equation v is equal to v0 plus at. Plug that in for the time, and it'll give you the velocity.